So now we want to talk about what's actually going on inside of the proplyd. So we know that the proplyd is this leftover disk of material. It used to be an accretion disk. It's now left over after the star has formed, so it stopped accreting, but now what's happening is that all this gas and dust is able to clump up and form planets. And so the classic theory is that just various sort of gravitational instabilities in here cause this to clump up in several places, and each of those clumps eventually becomes a planet. Okay, now the reality is a lot more complicated than that. Evidence indicates that it doesn't work nearly that smoothly. What actually more likely happens is you've got a cloud of material here in the proplyd, and as it gets very hot in here, as everything's being compressed, it gets hot, and the dust actually sticks together and melts as little droplets, and so you have little molten droplets in this very hot protoplanetary or proplyd disk. And so they form together in little nodules. These nodules stick together to make little small rocks. As things cool off, the little rocks start slamming into each other. And so if a little one hits a big one, it just adds to it, makes it bigger. If two kind of big ones hit each other, they blow themselves apart. Until eventually what happens is you start ending up with several fairly large clumps, what we call planetesimals. And these planetesimals are flying around, running into each other. Little things running into them make them bigger until they become what we call protoplanets. Protoplanets, then eventually things keep running into them, even planetesimals, and they eventually end up with just a small handful of things left over. Some of the leftover things that are out there continue flying around the solar system and run into things billions of years later. That gives us the meteorites and asteroids that hit Earth today. So this is the kind of violent process that's happening out there. Again, computer simulations, they've taken an artificial solar system and they've put hundreds or thousands, even millions in some cases, of these objects together, and after they're all done running around, what's left are a handful of larger bodies. We see evidence of this in some of the meteorites that we find, what we call chondritic meteorites. And inside the chondritic meteorites are these little nodules called chondrules. The chondrules are those things that form in the proplyd. We've got a handful of chondritic meteorites on campus, and when we get to this part of the semester, I like to have them available in the classroom so you can pick one up, and I like to tell people you're holding a rock that's actually older than the planet you're standing on. And so these are these chondrites, or chondritic meteorites. And so they are left over from the formation of the solar system, and they just only recently ran into Earth, and we find them. So the process is still ongoing. But this allows for these planets to build up. Now, one of the things that we notice is that for planets that are near the protosun or protostar, then they're going to be warmer than ones that are farther out. Well, remember, hydrogen is one of the most common things in the universe. We discovered that carbon and oxygen and nitrogen are byproducts of nuclear fusion inside stars. And so oxygen mixed with hydrogen makes water. Well, water is not stable close to the protostar, which is hot. But if you get far enough away, then water is going to be solid. And so if water is going to be solid, that means that your chondrites can be icy objects. That means you get more stuff to build things with. That would allow you to build even bigger planets. And so once the planets get big enough, they have enough gravity to actually pull in some more hydrogen and helium, which would be very rare on a small rocky world, and that makes even bigger planets. So you would get giant planets far from the young star and smaller planets up close. The smaller planets would be mostly rocky in nature, like Mercury, Venus, Earth, and Mars. And the outer planets would be gas giants, Jupiter, Saturn, Uranus, and Neptune. And so these icy things that are out there allow you to build bigger planets because there's just more stuff available. So again, for our own solar system, the inner worlds are small and rocky. The outer worlds are big and gassy. Now, technically, they're not really gas because if you squeeze the gas enough, it becomes liquid. So they're really liquid giants. But most books refer to them as gas giants. And again, they are gigantic. You could fit 1,000 Earths inside Jupiter, almost as many inside of Saturn, and you get like 100 Earths inside of Uranus or Neptune. Now, that's the basic idea. But it doesn't seem to entirely work because we know that Uranus and Neptune seem to fit this because the interiors of them have rock and ice. Okay, in fact, almost half of the world is actually icy stuff. Okay, on the inside, but the outer half is going to be hydrogen helium. But Jupiter and Saturn seem to be mostly hydrogen helium. In fact, they are almost entirely the same composition as the Sun. And so the other possibility for them exists that they directly formed out of the Proplyds, that you have clouds of gas that were simply swirling together, kind of like the original idea that you had some kind of instability. So some kind of shock wave passed through the Proplyd and just caused these things to directly coalesce out of that Proplyd. And so that means that they are simply just directly collapsing, which means they're going to have the exact same composition. So in fact, Jupiter has almost the exact same composition of the Sun. It does have a rocky interior, probably because of all the meteorites and asteroids that have run into it in the last 4.5 billion years since it formed. Saturn has a little bit more of an interior than Jupiter does, percentage-wise. It may have had more comets running into it. So question is, did Saturn try to form like Uranus and Neptune, which is similar to the way the Earth, Mercury, Venus, Earth, and Mars formed, or did Saturn form the way that Jupiter formed, which we think is an entirely different process? Some years ago, they had this big argument about whether Pluto should be a planet or not. Really, another argument is whether Jupiter should be considered the same kind of object as the rest of them, too, and maybe even Saturn. So, different ways that all this forms. Okay, the outer planets are going to form and be bigger than the inner planets. Okay, so that's what's happening here in the solar system, in this Proplyd. And so what will happen is that the big globule collapses, forms a protostar, okay, in the center of an accretion disk. After the protostar gets hot enough, it stops the accretion in the inner part right here, pushes away stuff, and then what happens is out beyond that you start building planets. Now initially what happens is in the inner area you don't have any icy stuff, so you just get the rocky planets. Out further you get some icy things and you can start building bigger planets. That would give you the giant planets. Okay, so now here's the thing, Jupiter forms. Jupiter is huge. And when Jupiter forms, it has an interesting thing that's going to happen. It's going to form, and then Saturn is likely going to form pretty early too. Now, Jupiter is always closer to the Sun, so it always keeps going around the Sun and getting in front of Saturn. That means Saturn's gravity pulls back on Jupiter, and Jupiter's gravity pulls forward on Saturn. The result is that Jupiter is going to slow down and then fall closer to the Sun, and then Saturn is going to speed up and move farther out from the Sun. And so what's going to happen is that these two planets formed closer to each other than they currently are, and then they separated. We call this planetary migration. The closer they form to each other, the closer in the inner planet goes, and the farther out the outer planet goes. Jupiter and Saturn have too similar of a composition to be explained by forming in their current locations. Now here's the other thing. As everything is flying around the sun, it's being separated into different isotopes, and so you can sort of tell from the isotopes that make up something where it formed. And what we find is that, bizarrely enough, Neptune has the signature of forming closer to the sun than Uranus does. So how does that happen? Well, back to my diagram here, including a few other things. So we got Jupiter and Saturn. Jupiter spirals inwards. Saturn pushes outwards. Okay, so Saturn is going to push outwards here. But that means it's going to now cause Neptune to go outwards, and also it's going to cause Uranus to go outwards. Neptune's closer, so it makes Neptune go really far out. So Neptune is now going really far out, okay, and so Uranus goes less far out, so they leapfrog each other. Now, what does that do? Remember, in the inner solar system, in the innermost part of the solar system, we have a whole bunch of rocky things swirling together to make planets. In the outer part of the solar system, we have a whole bunch of icy things that are trying to make bigger planets. What's going to happen is, as Jupiter moves inwards, it's going to shut off the process of planet formation, and the leftover rocky things are going to be trapped orbiting the sun, not able to get together. And that will give you a belt of rocky things orbiting the sun. That's the asteroid belt. These icy things, because Uranus and Neptune are moving outwards amongst all these icy things, it throws them out into these wild orbits really far out there. That is, well, gosh, Pluto is an icy thing in a really wild orbit really far out. Pluto is most likely a planetesimal that got kicked out when Uranus and Neptune moved outwards. That all these icy things that are out there form kind of an icy asteroid belt surrounding the rest of the solar system. We call that the Kuiper belt. If anything disrupts any of those objects in that Kuiper belt, they will dive in close to the sun. And when they dive in close to the sun, what's going to happen is the ice is going to start blowing off and give you a tail. We've actually found in the news recently of one of these objects out here that actually is in the process of its orbit having been recently disrupted and is slowly drifting inwards, and probably will develop a tail and become a comet within the next few decades. So this is what's happening here with all of this, and so this is our understanding as to how these planets all form. In fact, there's several things out here. The object Eris, which was an icy thing slightly larger than Pluto that was discovered, which is actually what kicked Pluto off the list of planets, because if Pluto was a planet, Eris and all these other icy things out there should also be planets. And so that's another one of these objects that got kicked out there. So don't feel sorry for Pluto for not being a planet anymore. Be excited for Pluto because it's now a leftover remnant of a planetesimal. All the other planetesimals got absorbed into the other planets. Now we get to see what an icy planetesimal actually looks like. And so that makes Pluto actually a very interesting object. So the solar system, we have that sun in the middle. We've got the inner planets. The inner planets are going to be the rocky planets. The outer planets are the gas giant planets. And then as Jupiter migrated inwards, it shut off formation of planets, made an asteroid belt. As Uranus and Neptune migrated outwards, it shoved all the other things really far out, and that made the Kuiper belt. Surrounding the entire solar system is also a giant, roughly spherical cloud of icy things called the Oort cloud. And again, if any of them get disrupted and dive in towards the sun, you get a comet. The Oort cloud, some of the Oort cloud may have actually formed in the globule originally as the sun was forming, and some of them may have been kicked out as all the planets rearranged.